All right, guys. So we'll do a little review of what we did yesterday. And then I'm going to unleash you on this handout that I kind of teased you with yesterday. So I call it the zeroth step. It's GCF, so it's going to be, it's what you always try. And then the other thing is going to be based on, like I said yesterday, how many terms you see. Actually tells you what method to try, thank God. Because one of the hardest things in math normally is, when do I do this, right? So GCF, and of course we learned this one too. The first thing is if there's 4 terms or more, what method do we use?
Section, is that what you're calling it? Or you?
Yeah, so you group them.
Grouping, okay.
There's one little example I forgot to give you yesterday. Of course, once we learn factoring, I'm going to start to figure out what it actually does for us. Because students are always sitting there going, are we playing with more numbers and letters? What the hell is this for? So I'm going to show you a few things it does for you. So a couple examples of both of these. So if I ask you to, the instructions just say factor. What do we got? Let's see. You can do it, Jeff. 25 a squared b c cubed minus 40 ab 5c. So if anyone wasn't here yesterday, might not know what the hell to do with that. Let's see. It's just basically undistribution. We're undistributing stuff. So we're dividing stuff out. This is a one-step deal. If you get it, or you don't situation. So this was kind of nice in a way. So you first look at the numbers. What number comes out of both? 5. You try to take out the biggest number that comes out. If you don't, you just do one more step and you take whatever else is still there. How many A's can it take out?
1.
How many B's?
1.
How many C's? 1. Sweet. Because you always look for the lowest power. Because that's the most you can take out of both. If you try to take more than one of these guys is going to freak out. So what's left here? 5. And then I just lose one of each letter. So I had 2, I got 1. I had 1, I lost it. I had 3, I got 2. 40 divided by 5 is 8. I had an A, I lost it. I had 5 B's, I took 1 away. I had a C, I lost it. Sure. And again, how do you check yourself? Well, we're saying that is this, so if I multiply this, it better freaking become this. That's our claim we're making, that these are the same. Yeah, I like it.
I had an error where I just tried to do the whole line without that. I erased it, but I did it where I tried to do the whole line, like all the B's, and then that left only 4, and then that.
Oh, like you put it all slammed together?
Yeah.
Or something?
I did miss the...
All right. As long as you don't do that again.
Yeah.
So when you're writing the second part, you take out each, like one of the A, B, C, you take out for both.
Yeah, because, so watch this. I'm going to ask you kind of a weird question now based on what you just asked me. Which one of these gets a 7?
Both.
They both do. So which one do I take? I take it out of both. Because which one would get this? They would both get this because I would distribute it to both. So whatever I'm taking out of everything because whatever I put in, I would put into everything. I'm just undoing this kind of process, right? That's why you can check it by just distributing it. That's what that means. That's where this would have come from, right? Okay, so that's GCF. And Doesn't matter how many terms I give you, you just do the same idea. It's got to come out of every single term. And here's some grouping. Let me just take it in just to give myself a break. Blah, 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 blah. Sure. You give me a good one. Give me a good one. Sure, sure, sure. I want to make a point out of this one. This is the one you got to be careful about, that negative.
I was mess up. I'll just go with the first one. Okay.
Oh.
I don't know what I'm doing. I'm just doing it.
So what is it that tells you what to do in this problem besides me saying grouping? What is it that tells you what to do here? What is it about the problem that tells you what to do?
Well, all of them don't have similar.
All right, good. I like it. So there's no GCF. So you always try GCF first. And then I look to see what tells me to do grouping here. Yeah, there's 4 terms. So if I have 4 or more terms and there's no like terms, I try grouping. You got to trust me on this. If there's 3 terms, there's a process we're going to do. If there's 2 terms, there's a different process I'm going to do. That's beautiful. You got to love that. Math doesn't normally say, hey man, this is what you try. This does. Shit. So you group it. What comes out of these 2? X squared. Now, in order for this to work, what's going to have to be in this parentheses?
The same.
The same thing. So then what do you have to take out of negative 2x to make it become x? What do you take out of negative 2x to make it become x? Negative 2.
Negative.
In fact, both of these can be divided by 2, but you need to take out a negative 2. That divided by negative 2 is x. Negative 12 divided by negative 2 is positive 6. You know you're on the right track because now you've got 2 terms and they share something. What do they share? Bedroom. No, they share x plus 6, which means I can take an x plus 6 out, and I'm left with
X to the second
x squared
minus 2.
minus 2.
I have a question.
Yes.
What about those 3?
The what now? The what? The which one?
X cubed and the 6 x squared and the
Beautiful.
2.
Who cares about the 2? You group. So my very first problem has nothing to do with that at all. It's this. I group it into 2 little groups, right? So what comes out of these 2 things? How many x is going to take out?
2x.
And then I write what's left. And then I attack this one the same way. So really, grouping is just 2 GCF problems. That's all. With an extra added, you know you're on the right track if these are the same. If they're not the same, more than likely you made a mistake. Most of the time it's a negative mistake. You've forgotten to factor a negative out. You have to change the sign. Yeah. Now. We did a lot yesterday with, what if x was 7 and blah, blah, blah. If you were here yesterday, you remember that. So that is just a number. This is a number. It's like the number 11. Because if I make x equal to something, then it is just a number after I put all this shit together. So it is a number. And I can factor a lot of numbers. Can I factor every number?
No.
No, not really. Right? 17, I can't break that up into something. Except as, 1 times 17. Right? So here, if I would have made that a 7, I couldn't have done this. it just would have been not factorable. It would have been prime. So I want you to be really careful about the fact that I am making things that will work. If I just randomly made a grouping of stuff, it more than likely wouldn't go anywhere. So one thing is, students, you got to understand how the process works. But then based on what I just said, you're like, well, what use is this shit then? Because you got to be really careful about it. But in reality, this kind of thing happens a lot. Right? So when you take business calculus, and you're like, oh, calculus. But you do a couple calculus steps, and then the rest of the problem is algebra. And very often the calculus leads you to something that is factorable. It's just kind of the way it is. Things actually work out, so things become factorable. Let me show you the first level of why this kind of thing is useful. What is it that I know that allows me to do something with this? What would I do with this? I would reduce it. Mm-hmm. What do I actually use to reduce it that you might not even realize you're using? 25 is 5 times 5. 40 is 5 times 8. Right, so we actually use the idea of factoring so that we can reduce something. You might not think about it like that, but you know a 5 goes into both because a 5 is a factor of both. So what the hell is my point? Here's my point. What if I had this? X cubed plus 6x squared minus 2x become a minus 12, right? Over, what you got, Jeff? 5x plus 30. Now just go with me for a second. Really? You guys semi with me right now? Mm-hmm. Mm-hmm. All right, now watch. I can reduce this because I can write it as a product of things where they share something, right? So, of course, those reduce. Of course, 5 divided by 5, gone. I can't can't reduce 2 and 30 or something because there's minuses and pluses. That's not multiplication, right? But what have we just figured out? The top is actually what? The top is actually that. And can you see what the bottom would actually be? What can you do with the bottom?
It's going to be 1.
You can take out a
X
5. And it'd be x plus 6. And then what would happen? What would happen? Yeah. Shit, yeah. And if I'm working with this expression because I'm trying to model the weather, and this is an equation that comes up, I'd much rather work with that equation than this freaking equation, right? Or this expression. Does that semi make sense? I mean, of course you have to understand that being able to simplify something is important. If you don't believe in that, then I can't help you. But this is disgusting. But now factoring gives me a way to possibly simplify it. Okay. All right.
Does that keep the 5 as well? On the bottom?
So
Yeah. So the actual result would be x squared minus 2 over 5.
Nice.
So if you plug in a value for x into this whole thing, it'll actually end up being the same as this. So how many fractions did we just reduce? An infinite number, because for every value of x, I get a different fraction. Right? Mm-hmm. Okay, maybe. All right. So any before I get into some new stuff, any specific questions or anything from what we've done or?
yesterday you had said there were times when you can switch the 2 middle ones and for a better result. And so how would you just, because it would just mix better number-wise? Or?
Oh, well, let me show you an example with this. So if it was x, if it had been given to me like this, and you start to group it, can you do anything with this?
No.
But do you see how those are the same things, aren't they?
Mm-hmm.
Right? So if I switch these, now I can actually do something there, right? This is something comes out of here, something comes out of there. So it's just to make it more general, it might not be just the 2 middle ones. It could be something else that's in the wrong place.
So in trying to mess with these on my own, I found that the sign is where I'm making an error, where I'm not bringing that sign right or messing that part up is where I'm.
Just drag them.
All right, so watch. I want to show you something. You mean that middle sign? You mean like this?
Right, because I tried it in here just to see in a fast environment if I get it right. And I switched the middle too for the first go around, and then I kept messing up my. Did I even do it right?
Yeah, you just left the plus out of there.
Okay.
And then you got to the same place we got, right?
Yes.
So now watch. It's interesting. There's going to be a process we're going to use where we're going to set up our own four-term expression. And we're going to have some choices we can make. And the choices basically always come down to, do I want it like this or do I want it like this? And one reason why I might want it the other way is because that stupid negative in the middle sucks.
Right.
Sucks rocks. So if I turn this around, which is something you'd always do. That's an old expression, sorry. It's like cool beans. Cool beans.
Bring it back, Jeff.
These are the same expression, right?
Right.
Now there's a slight possibility that if you do switch these, it actually becomes undoable. So you know, right? So if that happens, you're like, oh shit, I just got to go back and be careful. But you guys see now the middle term is positive. So let's try to factor this. What comes out of these two here? X. So you're left with x squared minus 2. What comes out of these two? 6. See, there's no negative to throw you off. Holy shit, right? And we saw an example of this the other day. Here, what was inside was x plus 6, right? Here, x plus 6 is on the outside. There, x squared minus 2 is on the outside. Here, x squared minus 2 is on the inside. So, but do you see how it's going to end up in the same place? What can I take out? X squared minus 2. And what's left? X plus 6. It's the same answer, of course, right? So I love it. That's a good point.
To avoid that middle.
Yeah, so if there's a minus in the middle and there's a plus there, you could switch those.
I was right.
Now again, if you do that, it might, if it's set up in a certain way, it might actually make it not factorable. Then you just put it back like shit. Right? But normally I bring this kind of thing up when we start creating our own, well, you'll see when we get there. And then you're like, you have a choice about which way to put this. Well, if you have a plus, put it there. Holy crap. Because then you don't make negative mistakes like you could over there. So right here, the mistake people would make is they'd have a minus here.
Right.
And then they just go, let me throw all that shit here and pray. But you cannot do the next step. The reason that this works is because these are the same. Otherwise, there's nothing common. How could you possibly go further? But I understand the optimism. All right, please, dear God, give me something. Partial credit.
Yeah.
All right, cool. I like it. Anything else about what we've done so far before we get into the next level?
Next.
Okay. So here's something a little strange. This skill right here is going to be completely necessary for the next level. What happened to the little dude? Get in there. Stay. All right. What numbers add to be, what you got, Jeff? Let's say 11 and multiply to be 28. Now maybe that should be a. Now don't say anything aloud. We stop you right there. But quiet. I want everybody just to think about this for a second. This is a problem I can give my math AE students. It's independent of factoring. It's just, are you able to play with numbers a little bit? All right? Think about this for just a few more seconds. So you can get the answer. All right, who's got the answer? 7 and 4, I like it, right? Now, how did you do that? How did you arrive at that? That might have been, those numbers might have been a little too obvious, I don't know. Because 28 is kind of like, the main way to factor 20 is 4 and 7, and that works. But one way to do this is to start, what is 28? Well, it's 28 and 1. But they would never add to be 11. Bah. And there's 14 times 2, right? But they don't add to be 11. Blah. And then 7 times 4, hey, they make 11. Do you guys start to understand what's happening there?
Made a factor tree, sort of.
Yeah, so one way to do it is to make a factor tree. And let me show you an example where that sucks, and thank God we have a different way we can do it. And none of my colleagues show that. They actually think I'm insane for showing you this, so think what you want to about what I just said. I'm getting some converts, though. Because anyway, we're about to do some factoring where this is the first step to factor. You've got to make sure that this kind of thing happens. So what numbers add to be, let me think about it for a second. Add to be 60 and, multiply to be 60 and add to be, so negative 60, let's say. Let's make it really freaky. Negative 60 and add to be, what do you want, Jeff? Sure. Negative 11. So, I'm not going to set you loose on this by yourself, because this is not an immediate obvious one. How many factors does 60 have? A lot. Which is one reason why we use 60 seconds, because you can break it up in a lot of different parts. Real quick word about that. The Babylonians used the base 60 number system because of the same reason. You can break it up into a lot of parts, and we stole that from them to make our 60 seconds, 60 minutes. Freaky ass history, but oh. So instead of starting with a factor tree, because there's so many freaking factors, let me make that happen. That's easy to make happen. Let me see if you guys agree with me.
Okay.
I need two numbers that add to be negative 11. Now they're going to multiply to be negative 60, so can they both be negative?
No.
No, because they got to multiply to be negative. One's got to be positive, one's got to be negative. So in that case, let me see if you guys, you've got to be able to play with numbers a little bit to really make this work. In that case, I need a positive and a negative number that make negative 11. So for example, like negative 12 and 1, don't they add to be negative 11? Do they multiply to be negative 6? Well, no, right? They multiply to be negative 12. So it's like a Price is Right game. I'm too low. Let's go higher. Negative 14 and what? Make negative 11? 3. What do they multiply to be? Not 60, I like it. Negative 42. Carry the 1. Look, we're getting closer, ain't we? Do you see what I'm saying? I mean, so it's less of a total guess, like, oh, let me do this and this and this. It's a little bit quicker to hone in. Now, of course, the more you're feeling comfortable with playing with numbers, the easier this whole thing is going to be. I'm almost there. What's negative 15 and 4? Negative 60. Kick ass. So that's the answer. So, now I could have just made a list of factors of 60, but how many people honestly would think of 4 and 15? Just off the top of your head. Not many of us. And it's not the automatically, if you're honest, there's 6 and 10, 2 and 30, 3 and 20, and then I'm like, okay, shit. But real quick, just to show you something nice. So for example, this is, what you got, Jeff? Let's do, this is 2 times 30, right? Now watch. Let me steal a factor of 2 from 30, so that becomes 4. And that's left with 15, and that's... I mean, so you could actually, there's a lot of processes. They all depend on your ability to play with numbers. I could actually make factors, and then 30 is 2 times 15. 2 times 2 times 15 is 4 times 15. There's another way to factor 60 that you wouldn't normally think of right off the bat. But it's all about playing with numbers. Okay, so let me give you this. This is, we'll see how this goes. For right now, just maybe glance at this side. There's a lot on this side we haven't talked about yet. But I want you to do this side, the non-colorful side. I want you to work on. And actually, let me try to force this to happen. Find at least one more person. And you're going to work with them, right? I like that reaction. You're like, I have a separate personality in my head. I'm a totally different physical person.
part of the door keeps getting bigger.
Oh, it's the, yeah, that's fine.
I don't like seeing the doors like that because I feel like somebody's sleeping or something. Especially if it's in a room.
Too little, too late. Alright.